In this video, I'm going to go over how to draw Lewis structures. And so we have 5 steps we have to follow. Step 1 is draw all atoms with correct number of valence electrons. And I'm going to start off with drawing the Lewis structure of this molecule, CH2F2. So to get our number of valence electrons, we have to look at the periodic table. Carbon is right here. Hydrogen is right here. Fluorine is right here. And those are on 1, 4, and 7 respectively. So when we draw out the valence electrons for each one of these atoms, it'll look like this. All right, and so step number 2, determine the center atom. Most Lewis structures, and especially when you're starting off, will all have one center atom that will be bonded to the rest of your atoms. And so if you just learned how to do Lewis structures, there's a good chance that almost all your practice problems will be like this. So you determine your center atom from 2 different things. It's the least electronegative atom, and it can't be hydrogen. And so remember that electronegativity increases from the bottom left going to the top right. So if we go up to our periodic table, stuff down here is going to be the least electronegative. It's going to increase and then ending at fluorine. Remember, the noble gases are very unelectronegative because they already have their full valence. So now if we're looking at our 3 different atoms, we immediately know our center atom won't be H because it just can never be hydrogen. Hydrogen can only make one bond, so it's never going to be in the middle of anything. And then between carbon and fluorine, we can see that fluorine is at the very top right. Fluorine is actually the most electronegative element, and carbon is less than that. So our least electronegative atom that can be the center atom for this problem is carbon. All right, and step 3, draw the center atom surrounded by everything else. And for this step, we're going to be including the valence electrons. Another important thing to remember is that if you are doing your problems and you find they make no sense, one thing might be that you've guessed your center atom wrong. Because in some problems, we might not know exactly which one is more electronegative, so you might have to guess. And it's important to know that if you guess wrong and you just can't get a Lewis structure to work with the atom you've picked for the middle, you can just go back to step number 2 and look at the rest of the center atoms and be like, I have to change it to a different one. That's completely fine. And so now that we have our center atom completely surrounded by everything else, we're ready for step 4, which is to draw a single bond between the center atom and everything else. So the way I'm going to do that is that a bond, a covalent bond, always represents the same exact thing. It represents 2 electrons. And so even when we are drawing it as a bond, what it really actually is just 2 electrons. So you can draw single bonds between the center atom and everything else, but you want to make sure that whenever you do this, you're connecting 2 dots, one on one atom and one on the other. So starting with carbon, I'm going to connect this electron to this one, and then I'm going to connect another electron to this electron. And so one electron can only participate in one bond, so we can't double up and connect multiple bonds to the same electron on any atom. And so now I'm going to connect these 2 to carbon to hydrogen, and I'm going to connect my last 2 here so that now my center atom is going to be bonded to everything else. One thing you know for sure in Lewis structures is that you're going to have every single atom bonded somewhere in the molecule. There's no chance you're going to have one of these F's or one of these H's just hanging out by itself. If it's given to you in the problem, it means it's bonded to this entire molecule. And so now I'm going to redraw so you can really tell what this looks like. So I'm going to start with my center atom and the 4 bonds that are coming off of it now, and then I'm going to attach the atoms that are at the other end of all of those bonds. And now my last step is I'm going to go through and look at the electrons and see which ones are still going to be in my picture because they weren't involved in any bonding. And in this case, I can see that all of my carbon electrons were part of bonds now, and all of my hydrogen electrons, they're also part of bonds. But fluorine, it still has 6 electrons on each fluorine that weren't involved in any bonding. So I need to draw those in my Lewis structure. So now we're ready for step 5. Check to see if each atom has a full valence, because that's the whole purpose of doing these Lewis structures, to figure out what type of molecule shape with what bonds and what extra electrons can these atoms form together that gives every single atom a full valence and makes it happy. And we're going to use our little equation that 2 electrons equal 1 bond to do this. All right, so starting with my hydrogens, they have 0 electrons left over, and they each have 1 bond, and that 1 bond literally just equals 2 electrons that now this carbon and this hydrogen are sharing. So when we add these together, 0 electrons plus 1 bond, we get a total of 2 electrons. And that means that this hydrogen is happy. So now let's do the hydrogen right under it. It's actually the same exact thing. This hydrogen has 0 electrons left over. Those were both used. Its only one was used in the bond. And it has 1 bond that it made with carbon. And that 1 bond equals 2 electrons. So when you add up 0 plus 2, that's 2 electrons, and this is also happy for hydrogen. Remember that hydrogen is only happy with 2 electrons because it's on that first row of the periodic table, and the first layer of orbitals can only accept 2 electrons, so hydrogen only wants to get 2 electrons. That's the same for helium. And in these Lewis structures, everything besides hydrogen and helium is going to want to get up to 8 electrons. So now let's go to carbon. This carbon has 0 electrons. All of its electrons got turned into bonds, and it has 4 bonds that are each sticking into it. And those 4 bonds add up to 8 electrons. So this carbon is also happy. And so now to do the fluorines, this fluorine has 6 electrons. We can just see those are still hanging out. They're not involved in any bonding. And this fluorine has 1 bond. And that 1 bond equals 2 electrons. And remember, I'm just getting that from this rule, because 2 electrons always equals 1 bond for all of these problems. And so 6 plus 2, that equals 8 electrons. So this fluorine is also happy. And then lastly, our fluorine on our bottom left, we have still 6 electrons plus 1 bond. That 1 bond equals 2 electrons. So 6 plus 2 equals 8 electrons. And this fluorine is also happy. So now step 5, we check to see if each atom has a full valence. In this case, it does. And so that leads us to, if yes, we're done. This structure is our Lewis structure. And so we only have one more thing we have to do, and that's our double check. And that means this is kind of a thing to make sure our chemistry grammar is correct, because it's a really important part of all of these problems that we have the exact same number of electrons that we were allowed in the beginning. So in step 1, if we go all the way back, we can see that in step 1 we had 4 plus 1 plus 1 plus 7 plus 7. That's a total of 20 electrons. And so that means that in step 5, we have to still have 20 electrons. And so if we look at everything at step 5, we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 just electrons that are on those 2 fluorines, right? And then we also have 4 bonds in our total molecule. And so 4 bonds, that's going to equal a total of 8 electrons. And so 12 plus 8 equals 20. And so this means our double check is correct. We didn't mess up and remove electrons or add them anywhere. We kept it consistent. And so that means that we're done. So the Lewis structure of CH2F2 is this. All right, so in this example, all we had to do was make our single bonds, and then we actually got to a completed structure. So in our next example, we're going to do a little bit of a harder problem where we get into what happens during step 5 if you connect everything with single bonds, but you don't have a full valence and everything. All right, so in this problem, we're going to solve the Lewis structure of HCN. So starting with step 1, we're going to draw all those atoms with the correct number of valence electrons. And again, I got the number of valence electrons because H is in our first column. C is in our fourth column. Remember, we're skipping all the transition metals to assign valence electrons. And then N is in our fifth column. So step 2, determine the center atom. It's the least electronegative atom, and it can't be H. So looking at this, we know it just can't be H, so it's not going to be that. And then for electronegativity, increasing from bottom left to top right, ending with fluorine as the most electronegative, we can see that nitrogen is closer to fluorine than carbon is. So nitrogen is more electronegative, which means that carbon is less, and that's going to be our center atom. So now step 3, draw the center atom surrounded by everything else. And step 4, draw a single bond between the center atom and everything else. So to show how I do that, remember that we draw our single bonds with just connecting 2 electrons, because all a bond is 2 electrons that are shared in between those 2 atoms. So I have it like this, and I have it like this. And it's also really important with these problems to always redraw so you can very clearly see what's happening. So right at this stage, I'm going to immediately redraw so that it's more clean. And the way I'm going to make it more clean is just to have the bonds drawn first and then to add the electrons afterwards and make sure everything's neat and tidy. So carbon has 2 electrons left over. Hydrogen doesn't have any because all of it was used in this bond, and nitrogen still has 4 that aren't involved in any bonds. And so now I'm at the point where I have to go to step 5 and check to see if each atom has a valence that's full. And that means that for H, it's going to have 2, and for everything else, it's going to have 8. So this H has 0 electrons. It only had 1 to begin with. It got used up. It has now 1 bond. That 1 bond equals 2 electrons, just because that's how chemistry is. So this hydrogen has a total of 2 electrons, and that means that it's happy. This carbon has 2 electrons left over, not doing anything, plus 2 bonds, which equals 4 electrons. So in total, this carbon has 2 plus 4, 6 electrons. So right now, this carbon is unhappy. And that means that we know this isn't our Lewis structure, because we'll only be done with our problem once all 3 atoms are completely happy. So now let's do nitrogen just to see where we are. Nitrogen has 4 electrons and 1 bond, which equals 2 electrons. So this nitrogen has a total of 6 electrons, and it's also unhappy. All right, so now we have to get into the second part of step 5. And so if yes, we would have been done, but we didn't have a full valence and everything. So that means we have to go to this. If no, we have 2 options to make everything completely happy. We can move electrons from one atom to another. It doesn't matter that carbon had these 4 electrons in the first place. We can just scooch those over to another atom. Or we can create double and triple bonds or some kind of combination of both those things. All right, so at this point, it's really just whatever you think, and there's no right way to do it. So you just kind of want to guess and then make a guess and see where it gets you. And so I'm just going to have this guess. I'm going to say, all right, let's try our first thing. Let's try to just move electrons from carbon to nitrogen and see if we can get a little bit closer. So I'm going to mark my changes in red, and I'm really just going to be moving these 2 extra electrons on carbon to nitrogen, just picking them up from one atom to another. So there's nothing about these electrons on carbon that means that carbon owns this and we can't just give them to another atom if that makes our problem get solved. And now I'm going to redraw below. So now I've just picked up those 2 electrons that used to be on carbon and moved them to nitrogen. And so now I'm going to go, and again, I have to do my step 5. I have to check to see if every atom has a full valence. And so for this one, I can see that my hydrogen is going to stay the same, right? It still has just 0 electrons and 1 bond. So that's just going to be 2 electrons, so it's happy. And now my carbon, it still has 2 bonds, but now it has 0 electrons. So overall, it has 4 electrons, so it's unhappy because it wants to have a full valence, it wants to be at 8. And now my nitrogen, that has its 1 bond, which equals 2 electrons, And now it has 6 electrons that are just hanging out around the nitrogen. So overall, this nitrogen now has 8 electrons, so it is really happy. So now, at our step 5, we have 2 out of 3 atoms have a full valence. They have the number of electrons that they want. But we can't finish the problem because we can only finish when every single atom is happy. So now let's go back to our original structure that we made, and we can see that in this case, moving the electrons didn't really help us, right? Because we took them away from carbon, and then nitrogen has enough. But now, if we want to take them away from nitrogen and put them to carbon, nitrogen won't have enough. So in this particular problem, moving electrons didn't really seem to help us. So let's do our other option, which is to create a double or a triple bond. So for this, I'm going to go back to my original structure that I had after step 4, and instead of moving these electrons, I'm just going to create a double bond. So to create my double bond, remember I'm not doing the red anymore, I'm just going to connect 2 electrons, one on carbon and one on nitrogen. And so now when I'm going to redraw, those 2 electrons won't exist anymore in the drawing because they're now represented by the bond, and I'll just have my individual electrons that are remaining around carbon and nitrogen. So now I have my double bond between carbon and nitrogen, and I have 1 remaining electron on carbon and 3 remaining electrons on nitrogen. So now I'm going to go back to step 5 and see, does everything have its full valence shell? And so for hydrogen, I can see it's remained the same, right? It has 0 electrons, it has 1 bond, which means that it has 2 electrons, and it's happy. And now carbon, now it has 1 electron, and it has 3 bonds. And so those 3 bonds equal 6 electrons, and so this has a total of 7 electrons. So closer, but this is still unhappy. And now nitrogen, it has 3 electrons, and it has 2 bonds, which equals 4 electrons. And so this also has a total of 7 electrons. So also unhappy, but now we're closer. And so now, if to keep going, we can kind of look at it and see, all right, would moving electrons help us in this case? And we can see that if we moved our 1 electron from carbon to nitrogen in this picture, now our carbon would just go back to having 6 electrons from its 3 bonds, so it wouldn't be happy. And if we moved any of the electrons from nitrogen to carbon, it wouldn't be happy. So really, we're just going to keep on pushing forward with our other option, and that's to create a triple bond. So again, with my changes in green, in my next picture, I'm going to connect these 2 electrons. And so I'll go ahead and redraw now. So now, when I connected these 2 last electrons, I created a triple bond between carbon and nitrogen. And now my H and my C have no extra electrons, and my nitrogen has 2 because it has 2 that just weren't involved in any bonding. So now I'm going to go back to step 5 and check to see if everything has a full valence. So once again, my hydrogen has 2 electrons coming from its 1 bond that's attached to it, and it has no electrons just hanging out on the hydrogen. My carbon now has 0 electrons, plus 4 bonds. Each bond is 2 electrons, so 4 bonds really equals 8 electrons. So this carbon is happy. And now my nitrogen has 2 electrons, plus 3 bonds. Each bond equals 2 electrons, this is really 6 electrons. And so now 2 plus 8, 2 plus 6, total of 8 electrons, and this nitrogen is happy. So now we've finally arrived at if yes, you're done on our step 5. So this is our final structure. This is the structure that allows every single atom to have a full valence. And so all I have to do now is to go back and do my double check to make sure that I didn't add or remove any electrons in any way, anywhere in the problem. So back to step 1. Originally I had 1 plus 4 plus 5 electrons, so I had a total of 10 electrons. And so now I have to just make sure that I have 10 electrons in my final structure. So now I'm going to go down, I'm going to look, and so in my final structure, I had 4 bonds plus 2 electrons. Those 4 bonds equal a total of 8 electrons. So 8 plus 2 does equal 10. So my double check works out. I used the correct number of electrons and I was able to make everything have a full valence. All right, so at the end of this problem, my final structure for HCN, Lewis structure, was. All right, I hope you guys feel like you have a better handle on Lewis structures. I'd say the most important thing is to remember that when you're just starting out, each Lewis structure problem can really take you 20 to 30 minutes. Don't feel like because you're not getting it right away, you're doing anything wrong. And only after you've done 10, 20 of these problems do you start to see the trends and you're able to do them quickly. And it's really important just to feel comfortable saying, oh, okay, I did the wrong thing. I'm going to go back to my previous step and I'm going to try again. The only way you get these problems is by guessing 3 or 4 wrong answers and then realizing what the answer has to be. All right, have a great day. Bye-bye.